We are, let's see. Well, we're going to do a little bit of that today, so we'll talk about it, okay? Okay. So, we did this front. Y'all can't see that. Great. So, according to what that favor is.
Can you type a letter recommendation to either Fraser's for me? Okay. I just need you to do that.
Okay. All right. So, we did this one on Monday. That has the 4 different types of factoring that we did, right? Or the 4 different types of solving that we did. The back of that was just one of each type, so you could check and see if you remember how to do that right. This page right here just has a bunch of different problems on it for you to practice on. We are going to do this bottom part, or some of this bottom part together. So this is discriminant stuff. So we're going to work on some of this together to make sure that you know how to do this. So remember, the discriminant is the part of the quadratic formula that is under the radical. So the discriminant is that b squared minus 4 times a times c. That's what the discriminant is. And what the discriminant tells you, so I'm going to use a big D to stand for discriminant. So if the discriminant is greater than 0, then that means it's a positive number. That means you're going to have 2 real solutions. Okay? If the discriminant is less than 0, that means it's a negative number. You're going to have 2 imaginary solutions, no real ones. If the discriminant is 0, you will only have 1 real solution. Because that means you're adding and subtracting 0, right? Because whatever's under the square root is what you add and subtract to the negative b. So if you add 0 or you subtract 0, you get the exact same thing, right? Now, quick reminder, this has to be in standard form before you can identify A, B, and C. If you don't put it in standard form first, then your A, B, and C are not accurate, okay? So in this case, we've got this one in standard form. So our b squared is going to be negative 3 squared. And then minus 4 times 3, because that's our A, times 2, because that's our C. And when you finish this math right here, I'm going to help us out just to make time be a little easier. That gets you negative 15. So interpreting this number is where this is at. What is this number? What does this number mean for your quadratic equation? 2 imaginary solutions, which means if it was a graph, right? So I'm going to sort of sketch it out over here. If it was a graph, it doesn't cross your x-axis. 2 imaginary solutions means it never crosses the x-axis. 2 real solutions means it crosses it 2 times, and 1 real solution means it just touches it, right? Okay, I'm going to let y'all do 6 and 7 on your own, because those are pretty simple. So it's just plug that stuff in, and then y'all can work on 6 and 7 if you want to. If you don't want to, I don't care. Having said that, I need to throw this out into the world for you. Remember I told you that you're turning this in for a grade, right? No, I didn't lie. I told you what I meant, and I will follow up with it. I don't care how much you do on this, okay? You can do a few problems, you can do half the problems, you can do all the problems. That's up to you. However, what's the purpose of this packet? To prepare you for your test. Your test is where you're going to get the results from this packet, right? So don't be stupid and just be like, well, I'm going to get one over on Miss Martin. I'm not going to do any of it. Woohoo, you didn't do any of your study guide. Fail your test. Go right ahead. You know what I'm saying? Like, you're going to have tomorrow in class to work on this and work on anything you're missing. You have that time in class. Don't be dumb. Actually work on it, okay? I'm going to put the answers up tomorrow, so you'll be able to see how you're doing on stuff. Actually, I may put them up this afternoon, but we'll see if I get that far. Okay, this next page front is factoring. All right, so we're going to work a few of these, okay? Now, this first one could be factored real simply, but I want us to go through the steps of when you have a more complicated one to factor, because I think that you need that refresher, and we can do it on a simple one, okay? So, we're going to make our big O X, and at the top of our X, we're going to put whatever A times C is. So, what is A and what is C in this problem? So, what is 1 times 6? 6. And at the bottom, we're going to put whatever B is. -7. So, we're looking for things that multiply to get 6, but add to get -7. -1 and -6. Right? Now, that means the -1 and the -6 are the product of our outside and our inside. So we've got a -1x and a -6x here and here. This is our x squared. It's always our first term. And this is our 6. That's always our last term, right? So now we just have to figure out, where did these answers come from? Just like a multiplication chart. So how did we get x squared right there? What does that have to be? Now, since these are both x's, it doesn't matter which one goes where, because they're the same thing. If they were numbers, if it was like 2x and 3x, then we would have to look at these and be like, what can I where can I put this that it makes sense, right? Then we're going to look at, what do we do to x to get -1x? So this is a -1. What do we do to x to get -6x? So that's a -6. So our factors, and then we double check. Is -6 times -1 6? Yes. So our factors are x minus 1 and x minus 6. And that's our answer. If it said just factor, if it just said factor. If it said solve, then we would have to set each one of those to 0 and solve them. But it doesn't say that. It just says factor. Does everybody see the difference in the two things? X minus 1 equals 0. X minus 6 equals 0. Because remember, if it said solve, then that means that we're looking for what could x be, right? What could x be to give us 0 on the other side? And so if we're saying what could x be to give us 0 on the other side, and you multiply these two things and you get 0 as an answer, one of those two things have to be 0. So that means that we would set it up as x minus 1 has to equal 0 and solve that. So that we'd say, oh, well, then x is 1. Because what's 1 minus 1? And then we would say, oh, or it could be that x minus 6 is 0. And if x minus 6 is 0, what would x be in that case? Oh, x could be 6. Okay? And these would be, if we were graphing, those would be our x-intercepts. Okay? Which they have some other names too. We're going to talk about that in a few minutes. We're not there yet. Okay, look at number 2 with me. Anything about number 2 jump out at you? There's no visible b, which means it's 0, right? 0b. There's no b. The b's cancel, right? Anything else jump out at you about number 2? They're both perfect squares. X squared is a perfect square. It's x times x. And 100 is a perfect square. It's 10 times 10. Right? So, and That's a minus sign in the middle. So this is what's known as the difference of two squares. If you have two perfect squares and you have a minus sign between those two perfect squares, this is the easiest thing to factor ever, because your factors are going to be, here and here is going to be the square root of the first term. What's the square root of x squared? X. So we're going to put x and x. And here is going to be the square root of the second term. That's going to be 10. And then we don't even have to think about our signs. How do you get a negative? One's got to be a positive, one's got to be a negative. And remember, this works out because if we did this times this, that would be a negative 10 and a positive 10, and they cancel each other out. Just like that. They're just gone. I was doing some stupid stuff in fourth hour, and one of my fourth hour people got to laughing at me, and I'm like, I'm trying to make this more interesting. I know you are tired. All right, what about number 4? Is it though? Is it though? It's not. Why is it not a perfect square? Difference of two squares. That dang P. Y'all see that P? If that P had not been there, it would have been. But because that P's there, it's not a difference of two squares. But Landon's right. We can factor that P out. Right? If we divide this by P, this one P cancels one of those P's. And we're left with 25P. And then over here, that P cancels with that P, and we have 16. Now, can we do anything else to this? Like, is it a difference of two squares down? No, why not? There's no P squared. That dang P again. Now, this would be your answer if the question was, factor this, please. Right? If that was your instructions. If it said, solve this, that means we need to find the value for P that would make this equal to 0. If it said, solve it. Okay? Or if it said, we'll get there in a second. If it said, solve it. Okay? If it said, solve it, then that means this P on the outside and this stuff here in the middle have to multiply to get 0. And how do you multiply two things and get 0? What do we know about those two things? One has to be 0. That means that it would either be P equals 0 or 25P minus 16 would equal 0. One of those two things has to be true. So then we would solve this one to figure out, well, what would P be to make this equal to 0? And by the time we get done, we figure out that P could be 0 or P could be 16/25, which is going to be like 0.7 something. .6. So that would be our two quadratic, no, our two x-intercepts, right? Which means it's going to be really close together if you're at 0 and 0.6. Okay, let's look at number 8 together. We're going to jump down to number 8. What do you notice? Huh? Everything can be factored by 4. So we're going to factor 4 out of all this stuff. Right? And when we do that, we have x squared, and then we have 5x, and then we have -6. Now, once we get here, we may be able to factor this. We just have to try and see. We may not be able to factor it. We just have to try and see. Like, that's all there is to it. If we can't factor it, we could always, if it's just factor, we'd leave it here. If we can factor it, then we go ahead and factor it out. So, what goes on top? What goes on bottom? So we're looking for things that multiply to get -6 but add to get 5. Two numbers that will multiply to get -6 but add to get 5. Are you okay? Uh-huh. 6 and -1. So that means in our box that we would make here, we've got 6x in one and -1x in the other. This is going to give us our x squared. This is going to give us our -6. That's this guy down here, right? So what's multiplying to get our x squareds? X and x. And then what do we do to x to get 6x? What do we do to x to get -1? So we've got this 4 on the outside. We can't throw it away. He's still there. Times x plus 6, x minus 6. Oh, x minus 1. My brain just were shut down for a second. Okay. Gordon, did that help maybe with some of your factoring? Okay. A lot of factoring is knowing multiplication facts, and if you're not great with multiplication facts, it makes it harder for you. The better you are with multiplication facts, the easier you see those patterns. And so have I ever told y'all the story about my daughter and the multiplication facts? Have I told y'all about that? So my daughter has now been out of high school for 5 years. She's 22. When she was in the 3rd grade, which was very, very, very long ago, that's when y'all learn multiplication facts, right? We discovered she could not memorize multiplication facts. Couldn't. We did everything. I made up songs for her to sing. I made flashcards. I made a PowerPoint game. We did the shaving cream on the desk, on the tables at our house. Had the cleanest tables ever. We did everything that you've ever heard of anybody ever doing to learn multiplication facts, and she could not memorize them. Just couldn't. Now, she learned to adjust for that. So what she would do is she would add things real fast. Like if it was 6 times 5, she would do 6 plus 6, 6 plus 6, add those together, and then add another 6. So she learned how to adjust for it, not be able to memorize those. Some people just can't memorize them. They just can't. However, I think some people just don't memorize them when they're younger. And it's not that they cannot do it. They just didn't for whatever reason. Maybe things were going on crazy in their life at that time. Maybe they missed a lot of school, or for whatever reason they just didn't get it. And they still can. I suggest if you are at your age and you're not great with multiplication facts, take a little time this summer, see if you can't learn them. It will help you next year. It'll help you a lot. Now, you still may not be great at it, but it ain't going to hurt you. By the way, I've decided that my summer get better project for myself, I got 2 going on. 2 summer projects to get better, to become a better person, better version of me. Number 1, I got to start working out because I ain't. Number 2, I'm going to try to learn Spanish again for about the 15th time. I downloaded a podcast the other day that was supposed to be great. I didn't understand any of it. Like, literally I couldn't even understand when the guy was talking English. Like, I just couldn't. That's not going to work for me. I want to try something different. I don't know what, though. Okay. And I want to read an actual book. All right, so I'm going to leave the rest of those factoring ones for y'all to work on. That section 2 that says solving, that's just the different types of solving that you could do, and I'm going to leave those for you. So you have those to practice on if you want to. It's front and back. And then let's talk about this section 3, graphing. Okay? So, the top part of this is just finding the vertex. That's all it's asking you to do is find the vertex. And we have these equations in different formats. So we have vertex form. In vertex form, now, first of all, before I write this, remember, it could say y equals, but it could also say f of x, and those mean the same thing. F of x is just function of x, and function of x and y are interchangeable, okay? So it would be a parenthesis x minus h squared plus k, and that's where h and k are your vertex, okay? That's vertex form. And so, like, if you look at number 1, that's in vertex form. So we don't have to do anything to define our vertex. Our vertex is right there. What would our vertex be here? You're almost right, Jordan. Almost right. Does anybody know where Jordan made her tiny, tiny, tiny error? It's -2. Now, why is it -2? Because remember, that's minus. And so if that's minus, but you have a plus, how did you minus and get a plus? You have to be minus and a negative. So it's -2 and then 5. Right? If you look at number 3, what would our vertex be on number 3? +1. And then what's our 0? If it's not there, what could we add that doesn't change anything? 0. So it must be a 0. That means our vertex is 1, 0. Yes, sir. Yes, sir. Okay. Mark off number 5 and number 7. I'm not going to ask you to do any like that. We didn't cover those, and so I'll let your Algebra 2 teacher teach you that one. Okay. So let's look at number 2 here. Now, number 2 is not in vertex form. What form is number 2 in? Standard form. So remember, standard form is ax squared plus bx plus c. And it could be y equals, or it could be f of x. They're interchangeable. And if you have standard form, but you want to find the vertex, you got this little teeny tiny little formula. And your little teeny tiny little formula is b divided by -2a. And that gets you h, your h value for your vertex. And then once you have your h value, you stick it in the place of x in your equation. And that gets you the k value of your vertex. Okay, so if we're looking at this one right here, what is our b in this thing? It would be 0. Let's talk about why it's 0. We don't have an x in there, right? When you don't have it in there, it's 0x. There's not one, right? So this is going to be 0 over -2 times -2. But does it even matter what a is? You are right in that you can't divide by 0. That's an accurate statement, but that's not what we're doing here. We're dividing 0 by something. And you can divide 0 by something. If I have no money in my pocket, but I say I'm going to give y'all I'm going to give y'all an equal amount of everything I got. My phone is blowing up over there, isn't it? It must be. I mean, like, there's a very limited number of people who can get through my phone during the day, so it kind of concerns me. I will, but I'm going to try to finish this up first. If it's that much of an emergency, they should call instead of text. So hopefully it's just something where, like, my husband's trying to remind me of something or something like that. So, that would require him to walk in the kitchen, and he don't do that, so. Okay, hope you don't ever see this video. Although I didn't say nothing that wasn't true. Alright, so that's going to be 0, right? That's a 0. And then if we put that 0 in where x is, and we do that math to find our k value, then what's that give us for k? It's going to be negative 3 because 0 squared is 0. 0 times negative 2 is 0. 0 minus 3 is negative 3. Bigger workspaces, yeah. I'll make sure you have big enough workspaces. Or something. Okay, so right here. If we look at this, if we're trying to find our h, what is our b value on this? It's 0 again. Once again, it doesn't matter what our a is, what we're dividing by, because if you have 0 and you divide it into groups, how much is in each group? 0, right? So our x part of our vertex is 0. If we plug that 0 into our equation, what do we get for our y? So this vertex is at the origin, 0, 0. I'm going to let y'all do those other two on your own if you want to, if you think you need that extra practice. 9 and 10. I am not going to be concerned about you knowing stretch, shrink, standard. I'm not worried about that. You do need to know if it opens up or down. So number 9, does it open up or down? Did you even look at the numbers? Why is it open down, Jordan? The A. Yep. The A is a negative. When the A is a negative, it opens down. What about number 10? It opens up. What's our A value for 10? Understood 1. Yeah. Just for your benefit, like I said, you don't have to know this. Number 10 would be called standard because it's 1. 1 is called standard. And number 9 would be a vertical stretch. Vertical stretch. If you think of a rubber band if you pull up on a rubber band, it looks skinnier, even though it's really not skinnier, but it looks skinnier. Okay, number 11. I've referenced number 11 numerous times today. And I keep saying, oh, we haven't talked about that. I'm not going to test you on number 11. I just want you to know this. When we talk about the solution to a quadratic, we're talking about its x-intercepts. We also call them sometimes roots. You'll find the roots. And believe it or not, we sometimes call them the zeros. So solution, x-intercept, roots, zeros all mean the same thing. And it's all finding where your graph crosses the x-axis. All of those things. Okay, so we're going to talk about graphing these a little bit. So if you've got one that's in vertex form like this first one is, easiest thing to do is graph your vertex. So what would our vertex be in this? -5, -3. I know my point's going to be off. I'm just warning y'all, okay? So, because I don't have my glasses on, so I can't see it well enough. So that's our vertex. And then we know that line right through there is our axis of symmetry. So if we find a point on one side, we can match a point on the other side. So for any point we know it's mirror image point, right? So when you look at this axis of symmetry gives you an idea of where you probably need to pick your x from. So we don't want to go way over here because we know that sucker is not going to be way over here, right? That's a 2. Our A is a 2, which tells us this is going to be fairly skinny. So if it's going to be fairly skinny, what x value do y'all want to pick to put another point in? Okay, so if we put -4 in there, that's going to give us 1 squared times 2 minus 3, which gives me -1. So -4, -1. And then that means we also have that matching guy over here on this side. And technically, we should go ahead and find one more point. But just for the sake of time, I'm just going to sketch it out, okay? You really want to have 5 points. That gives you a better idea of where it's going. Alrighty? Okay, number 13. Your best bet on number 13, well, First of all, when it's like this, they've given you your x-intercepts. You just haven't realized it yet. So remember, this is already factored out. In factored form, we know that if we put 0 in for y, that's where our x-axis is, right? So if we put 0 in here and we get this, then that means that this is not a 0. Negative 1/2 is not a 0. So that means that x plus 5 would have to be 0 for this to come out to be a 0. Or x minus 3 would have to be 0 for this to come out to be a 0. That means if x plus 5 were 0, what would x have to be to make that a true statement? And if x minus 3 were 0, what would x have to be to make that a true statement? 3. So those are our two x-intercepts. So we've got negative 5 as one x-intercept, and we've got 3 as the other x-intercept. And we know that right smack dab in the middle of them is our axis of symmetry. So we could count over, so there's 8 spaces between them. So if we count over 4, 1, 2, 3, 4, and we draw our line right through here, we know that our vertex has to be on that line somewhere. And that value right there is negative 1. So if we put negative 1 in for x, we'll find out what our y value is for our vertex. So negative 1 plus 5 is what? 4. Negative 1 minus 3 is negative 4. So I've got negative 4 times positive 4 times negative 1/2, positive 8, right? So we know that that's where our vertex is going to land right there. So that gives us enough of an idea that we can sketch out this graph. I always draw them lopsided. It don't matter how hard I try. I still draw them lopsided. Okay, so on 14, you could either just plug points in, plug in x's, find values for y, plot the points. Or you can find your vertex and then go from there. I'm a big proponent of finding your vertex. Because if you find your vertex, then you half your work. You only have to do half the rest of the work. Where otherwise, you got to find 5 different points that fit on this graph. And if you find your vertex, you've had to find your vertex and maybe 2 more. Maybe 2 more, right? So if we find our vertex, right, so we're going to do b over negative 2a, right? What's our b? And then our a is 1, so that's just going to be negative 2 on the bottom, right? So that's going to be negative 2. So we know our vertex is going to be on this axis. Oh, I just drew it on the wrong side because I'm crazy. Our vertex is going to be along that line, right, somewhere. And to find out where, we're just going to take that negative 2 and stick it in that equation. So negative 2 squared plus 4 times negative 2 minus 6. So 4, negative 8, negative 6. Negative 10. So this is where our vertex is, way the crap down here. Right? Now, another thing we could do, we could just pick some values, plug them in. We could also find our x-intercepts. We could factor that guy and figure out what our x-intercepts would be if it's factorable. Right? Sometimes they're not factorable. And this is actually one that's not. It just dawned on me that it's not factorable. Because what are things that multiply to get 6? 3 and 2. 1 and 6. Do those combine in any way to get 4? No, they won't combine to get 4. That doesn't mean it's imaginary. That just means it's not going to be whole numbers. If it was factorable, it would be whole numbers, and it's not going to be. One of them is going to have to be a decimal at least, maybe both, but one of them at least. So what I would suggest doing is let's start with. I figure it's going to go through 0. Don't y'all think it's going to go through 0? So let's put 0 in there and see what we get. So what do you get when x is 0? Negative 6. That means that we've got a matching point over here, right? And then we could pick like maybe, I don't know, what do y'all think? 2? Do you think 2 would be a good one to put in there? So we put 2 in there. So 2 squared plus 4 times 2 minus 6. That's going to be 8 and 4. 6. Yeah. That help? So what do we say it was? 2, 6 here. And that means over here it's going to be negative 6, 6, like that, I think. I don't have my glasses on, so I can't really see what I'm doing. I'm just sort of guessing. Oh, totally missed that line, that point. We'll just... You'll see how that worked? And see how it's not going through nice, pretty whole numbers down here? Because we can't factor it. So it's going to be... it's not imaginary because it does cross. It's just not nice, pretty whole numbers. And that's what happens when you can't factor it. They're not whole numbers. If they were whole numbers, you could factor it. Okay? Okay. That's your study guide for your test. The rest is your choice. You do as much or as little as you want to. There is graph paper over there if you want to practice graphing them. Okay? So you can pick any equation on here and practice graphing.